Morning students, after the classification of crystal and solids, now I am going to start a crystal and lattice and the unit cell. So before going to crystal lattice, we have to know what is a lattice, what is motif and what is a crystal structure. So lattice is the arrangement of spatial arrangement of geometrical points is known as lattice, and this lattice, it is the arrangement of geometrical points are arranged here in a regular pattern, and these points of a lattice is known as a lattice point. Understood? Next is motif, and these motifs are the object, that is an atom or molecules or ions, which may present on a lattice site or lattice point in a regular or identical pattern is known as a motif. Understood? So motif is here represented here on the lattice sites or lattice point. Understood? Which are on the lattice, which are on the lattice point or lattice sites. What motif? And crystal structure. So crystal structure means the lattice points and motifs both get combined and forms a structure, and that structure is known as a crystal structure. If you take the just example of sugar that are in a crystal structures, understood? The crystal structure, the crystal lattice and the motif both gets the arrangement is known as crystal structure. Understood? This about lattice, motif and crystal structure. Understood? So here, in case of lattice, there are two types, that is two-dimensional and three-dimensional. So two-dimensional lattices are formed, that is x-plane and y-plane. Understood? In this manner. In this manner. In this manner, two-dimensional structure takes place. In this manner or in this manner, the two-dimensional structures takes place. In case that is another is three-dimensional crystal lattice, that is x, y, and z. Understood? So that is represented here. Understood? So this is a three-dimensional structure. So totally 8 lattice points are present in a cubic crystal. So here see the 8 lattice points: 1, 2, 3, 4, 5, 6, 7, and 8. 8 lattice points. Understood? So you can just assume here this one, 1, 2, and the back side 3, 4, 5, 6. Understood? The later lattice points which are present in a crystal structure, cubic crystal structure, and these corners are represented as one gate. So each corner of a particle or atom or ion or molecule is represented as 1/8. Understood? This is what about the crystal lattice. So two-dimensional and three-dimensional possibilities. So in case of three-dimensional, there are 14 crystal lattices are possible. And these 14 crystal lattices which are possible is known as Bravais lattice. Is known as Bravais lattice. And the characteristics of these crystalline lattices are, so that each point in a lattice is called lattice point. So each point in a lattice is called lattice point. Each point in a crystal lattice represents one constituent particle, which may be an atom, molecule or ion. So you can see in this diagram, you can analyze which may be an atom or molecule or ion. So the corners must be an atom, otherwise molecule, otherwise an ion. Understood? But not the three, any one. Next, the lattice points are joined by straight lines. Understood? To know the geometry of lattice. So, if you see this diagram, two-dimensional and three-dimensional, so lattice points are joined through a straight line, and to know the geometry of what lattice. So here, in case of two-dimensional, it is 90 degree, and in case of three-dimensional, x and y is having a three-dimensional. Understood? And in case of y and z, and in case of x and z, it varies or mutually may or may not be mutually perpendicular. Understood? So this is about the characteristics of crystalline solids. And next is unit cell. A structural unit which is formed, a structural unit is formed in a crystal structure is called unit cell. So if you take the example like this, if you take the example here, it is of an unit cell. So this is one of the crystal structure. So now the crystal structure, and these crystal structures are made into further blocks. Understood? And each block of a crystal structure represents one unit cell, and this is arranged in a regular pattern. In a regular pattern. Understood? This is what about the unit cell. And next, these unit cells are further characterized on their depending on the crystalline lattices like this. See here in the diagram here. So three-dimensional crystal structure having is formed with three edges, that is one is A and one is B and one is C. Understood? Like X and Y and Z. So three edges is formed, and these are having geometrical points like alpha, beta, and another is gamma. So totally three edges, the three geometrical points forms 6 parameters in case of a three-dimensional crystalline structure. Understood? This is in case of a crystalline structure. 6 parameters are present. That is A, B, C, and alpha, beta, and gamma. So this is about what the characteristics of a crystal lattice and example that is a unit cell, and the unit cells are further classified into two types, that is primitive cubic unit cell and centered cubic unit cell. I will explain this one in the next class.